Hello, welcome to Life of Chemistry. Today I will discuss about permanganometry and I will provide you some questions for your lab quiz test or viva. I think which will help you a lot. And if you like this video, don't forget to subscribe my channel. So without wasting your time, let's start. I have divided my class into 4 sections. First of all, we will know what is permanganometry. Then we will discuss why KMnO4 is called as secondary standard solution, and then we will know how to prepare KMnO4 solution, and finally we will discuss how to standardize KMnO4 solution. So what is permanganometry? Permanganometry is basically the volumetric titrations in which KMnO4 acts as a very strong oxidizing agent. As we all know, in acidic medium, MnO4- accepts 5 electron and gives Mn2+, and the reduction potential value is 1.51 volt. That is quite large, but it also acts as an oxidizing agent in neutral medium, but in that case the reduction potential value is quite low, that is 0.59 volt. Okay, and now if we see the Nernst equation in acidic medium, then we will see that the formal potential value of MnO4- by Mn2+ couple is largely dependent on H+ ion concentration, that is the pH. Now if we increases the concentration of H+ ion, that is decreases the pH, then the formal potential value of MnO4- by Mn2+ couple will increase, that is MnO4- will act as more stronger oxidizing agent. So what we can conclude from this, that MnO4 is much stronger oxidizing agent in acidic medium than neutral medium. So we need to use a suitable acid to increase its reduction potential. Now the question arises, what will be the suitable acid for permanganometry? The general acids we use in our laboratory is HNO3, HCl and H2SO. HNO3 cannot be used in permanganometry as it is an oxidizing acid, so it will interfere in permanganometry. HCl can be used in permanganometry, but in that case we need to remember one thing, that is E0 of Cl2 by Cl- couple is 1.36 volt, less than 1.51 volt, that is that of MnO4- by Mn2+ couple. So it indicates that MnO4- will easily oxidize Cl- to Cl2. So in that case we need to use Zimmermann-Reinhardt solution, but we will discuss that thing later. H2SO4 is the best acid for permanganometry. So whenever we will perform permanganometry in laboratory, we try to use H2SO4 as an acid, but if there is no way, then we can use HCl as acid, but we need to use Zimmermann-Reinhardt solution in that case. So here is the equation which shows that MnO4- oxidizes Cl- to Cl2. Okay, let's come to our next point, why KMnO4 is secondary standard solution. To answer this question, first of all we need to know that what is a primary standard solution and what is a secondary standard solution. Primary standard solutions are those solutions which strength doesn't change with time, and secondary standard solutions are those solutions which strength changes with time. Okay, for example, if you prepared a solution of strength say 1 normal, and if you measure the strength after 1 month or 2 months or 3 months, if the strength remains constant, that is 1 normal, then it will be a primary standard solution. If the strength changes with time, then it will be a secondary standard solution. Okay. For example, dichromate solution is a primary standard solution and NaOH solution is a secondary standard solution. KMnO4 is a secondary standard solution because KMnO4 is never obtained pure and perfectly free from MnO2. So if we try to make a KMnO4 solution of certain strength and we calculate the required weight of KMnO4, let's say it becomes 1 gram. So if we take 1 gram of KMnO4, then we doesn't know how much of MnO2 is contaminated with this KMnO4. So we will never obtain a perfect strength of KMnO4 from this way. Okay. The second problem comes is that KMnO4 spontaneously undergoes photodecomposition. So as a result, its strength always changes. Again, the ordinary distilled water always contains some amount of organic reducing agent, and these organic reducing agents are oxidized by KMnO4 and the KMnO4 reduced to MnO2. As a result, its strength changes, and the presence of MnO2 is very dangerous as it catalyzes the decomposition of KMnO4 on keeping. Okay, so here is the equation which shows the decomposition of MnO4 minus into MnO2. So let's come to our next point, how to prepare KMnO4 solution. As we mentioned before, KMnO4 cannot be prepared accurately, okay, because of contamination of MnO2. So we need to take some extra amount of KMnO4 and then we need to standardize it to get the perfect strength of it. And the second point is, if we try to filter out that MnO2, we cannot use our ordinary filter paper because the filter paper will be oxidized and the filter will not happen, okay, at all. So we will use glass wool to filter KMnO4 solution. And the next point is, if we try to preserve a KMnO4 solution, then we will have to prevent the sunlight because KMnO4 photodecomposes. So for this purpose, we need to preserve the KMnO4 solution in a amber colored bottle, okay, and we will have to place that bottle in a dark place with a black paper folding the bottle. As a result, the sunlight will not able to come in contact with KMnO4 solution and its strength will not change sharply. Let's come to our last point, how to standardize KMnO4 solution. KMnO4 is generally standardized with a primary standard oxalic acid solution. MnO4 minus quantitatively oxidizes oxalic acid to carbon dioxide and itself reduced to Mn2 plus. Okay, now let's come to the procedure. This reaction is done at 2 normal H2SO4 medium, and initially the reaction mixture is heated at 70 to 80 degrees centigrade, which indicated by the first appearance of the bubble. Okay, now when we add KMnO4 from the burette, first few drops added very slowly. There is a reason which we'll discuss later, and there is no required of subsequent heating. Okay, let's come why heating is required, why initial heating is required. Because the reaction of MnO4 minus with oxalic acid needs a high activation energy. Okay, as a result we need to heat the solution, but the temperature doesn't go above 70 to 80 degrees centigrade, because above that temperature the oxalate ion become to decomposes. Okay, so the initial temperature should be maintained at 70 to 80 degrees centigrade. And why subsequent heating is not required? Because the Mn2 plus formed in the reaction acts as an catalyst. This is an auto catalyst. When some amount of Mn2 plus is prepared in the reaction mixture, it auto catalyzes the reaction, so subsequent heating is not required. Okay, why the temperature should not fall below 60 degrees centigrade? Because during the reaction there is a formation of complex which is reddish brown in color and unstable above 60 degrees centigrade. If the temperature falls below 60 degrees centigrade, then we will observe the complex and we will be misguided that the end point of the reaction has come. Okay, now how to detect the end point? Okay, so when the pink color of permanganate will persist for 30 seconds, then we confirm the end of the permanganometric titration. The end point lasts only 30 seconds because the MnO4 minus the excess amount of MnO4 minus, which shows the pink color, reacts with Mn2 plus and forms MnO2. As a result, the color of MnO4 minus disappears after 30 seconds. Okay, thanks for watching. If you like this video, please subscribe to my channel and press the bell icon.